But getting started, we're talking about parallel lines today. So, again, this PDF file is uploaded if you did want to print it yourself. I will be handing you copies next week. Parallel lines cut by a transversal. And I'm going to draw that in on our picture in a second. Create different angle pairs. And some of this vocabulary we had last week that are all equal in measure. Or the angle pairs will be supplementary. And remember, supplementary means that they add to 180 degrees. Okay. So if I draw in a transversal here, what we are starting with is a set of parallel lines. And just to review what parallel lines are two lines that never intersect or meet. All right. They run the same direction forever and ever. So we can talk about line L. I'm going to name it with a lowercase l, and line M. And the little notation we might say or see in our questions is line L is parallel to line M. So this double vertical bar here is the symbol for the word parallel. So that's just a little new math symbol for you. But if L and M are parallel and they are cut by a transversal, so if I draw in a line going in an opposite direction, that is called the transversal. So that's this line here. Let's call that line A. Okay. So A is crisscrossing lines L and M, and what happens is you create sets of angles. So M and L didn't have any angles formed at first, but now we have 4 angles at this intersection and 4 more angles down here. And there's relationships between those and names for each of those. So that's what we're going to look at in these theorems or definitions below. So the first one reads, if two lines meet at a point, the vertical angles are equal. So here in this first set, we have one set of vertical angles. There's other ones up and down from there, and other vertical angles down in the second set as well. Okay, so remember your vertical angles. If we drew a little picture to help remember from our other notes, turn my camera off. There we are. Sorry. I think it slows down when I have my camera on. Those are the vertical angles. So if this one was, let's say, 40 degrees over here, the one on the left and the one on the right would be equal to each other. Some other equal angle pairs. So actually, these first 4 sentences, all sets of angles here are going to be equal. So reading the next one, if 2 parallel lines are cut by a transversal, the alternate interior angles are, I guess the word are was already there, wasn't it, Miss Locke? Are equal or are congruent. I'm going to use that vocab word. Okay. So a little picture here of our alternate interior angles. Now, how I like to talk about the alternate interior angles is we are alternating sides of our transversal. So again, if this here is our transversal for our picture, we've numbered all the angles, angle 1, angle 2, angle 3, angle 4, 5, 6, 7, and 8. Alternate interior angles form what I call a little Z. One is on the left side of that transversal here. The other one is on the right side of the transversal. So I'm going to pick up my yellow pen for a second. I'm going to draw in a little Z. If I trace over, come down my transversal and go across, we have angles 3 will be equal to angle 6. So whatever the measure of angle 3 is, if this one is, let's say, 50 degrees, angle 6 will also be 50 degrees. Okay, and again, I'm making that measure up just for explanation's sake as we're looking at it. The next word here is if 2 lines are cut by a transversal, the alternate exterior angles are congruent. And again, congruent is just a fancy word for equals. Now, the reason alternate exterior, so interior means from this parallel line and this parallel line, 3 and 6, we're inside of them. Alternate exterior are going to be angles 1 and 8. Okay, because that's outside. So this is 1 on the left side of that transversal, and 8 is outside the parallel line. So remember, here is inside, and this is outside. Okay, so 1 and 8 would be considered alternate exterior, and those measures would be equal to each other. So if we did have that angle 3 in here, and I'm going to try to zoom in a little bit. If we have that angle 3 is 50 degrees, angle 1 right next door there is going to be 130 degrees. And how did I get that? Well, remember, they're supplementary. So 180 minus the 50 does leave us with 130 degrees. So that if that outside angle 1 is 130, then this outside angle is 130. Now, we kind of knew that because of the 50 degrees there, but they're not always going to give us each of the measures, and we have to kind of see their relationships so we can set up equations a little bit later. Okay. Last one is corresponding angles. So what I am going to do for a second here is I'm going to erase a little bit of my picture for so I can use it to explain another question. Now, if you just want to draw another diagram, you can. All right. What we're going to go back to is corresponding angles. And what I like to say with our corresponding angles is, again, they are also congruent. But I call these my copy, C, and the word corresponding has a C in it, right? So I call these my copy, and P, ponding, corresponding, paste angles. So that's my little trick to remember copy and paste. So looking back at the picture here, let's see if I can deselect some of this. Right? Looking at the picture there, if I copy angle 1 from this like 4 angles, if I could copy that and move it down to here, what does it paste onto? So if we start at angle 1, I kind of circled, and we paste it down here, does that look like a little pokeball? Sorry, I'm kind of getting sidetracked by my diagram. But if angle 1 is in that top left position of the picture, angle 5 is in that same position. Okay, so if I copy angle 1's measure down here, angle 5 would be equal. So our copy and paste angles would make angle 1 congruent or equal to angle 5. It also copy angle 2 to the top right position onto angle 6. So that might help that case there, that those corresponding angles might help you solve some questions in a minute. All right. So those are your angle pairs that are equal. Vertical angles are always equal in measure or congruent. Alternate interior, exterior, and corresponding angles are angles that are congruent to each other. So those kind of are all related. The next 3 sets of pairs of angles are always supplementary. Okay, and again, supplementary, the S kind of looks like an 8 if we draw that in. But those are angles that add to 180 degrees. So we have linear pairs of angles are supplementary, and I'm going to abbreviate SUPP. The other 2 sets are considered consecutive or same side interior angles. So consecutive, remember consecutive means one after another. So like if I talked about consecutive numbers, it'd be 1, 2, 3. Consecutive angles are going to be on the same side of a transversal. So I'll explain that with this picture over here in a second. But we also have consecutive exterior angles, okay? And those are all supplementary to each other. So looking at the picture, let's zoom out. There we go. So looking at our picture here, we have a bunch of linear pairs. So let me go back up here to linear pairs. 1 and 2 would be a linear pair. 2 with 4 would be a linear pair. 3 with 4, because those are along a line. So there's a lot of linear paired angles together in our picture. But our same side interior angles are going to be 4, which appears obtuse here, right? That one looks obtuse. And that's inside our parallel line. If I keep going down my transversal and stay inside my parallel line, I have this angle 6. Well, that's baby size. That's only open this much here. So that one's acute. So like the question, like the last set of words up top, those all look the same. Here we have a big one and a small one. They can't be equal. Something more than 90 degrees and something less than 90 degrees can't equal each other. So what those two are always going to do is add to 180. So we can write a little problem here. The measure of angle 4, so this little m that I'm writing stands for the word measure. So this is new notation here. Measure of angle 4 added to the measure of angle 6. So again, though that relationship is same side interior, they add to equal 180. So if angle 4 was represented by an expression, let's say like 2x plus 8, and then measure of angle 6 was like x minus 10, again, I'm making those up. What we would do with those two expressions is we take the measure of angle 4 and add it to the measure of angle 6 to equal out to 180. So again, we're going to kind of extend into some algebra problems in a minute here. But if these two angles were represented by this expression and this expression, we would combine like terms and set equal to 180. Same thing with same side exterior angles. So same side exterior is if we talk about angle 1, that's outside of our parallel lines. So again, if these are parallel lines, we have inside and 1 is outside. Well, if 1's outside and on the left of the transversal, I'm sorry, same side, we're looking to the left and outside down here, which would be angle 7. So an example of a same side exterior would be angle 1, the measure of angle 1 would add to the measure of angle 7 to give us 180 degrees as well. So those are some of the vocabulary words that we're going to be looking at. Let's flip the page. So that was just the front page of notes here. We're going to scroll the page and do some examples. Okay. So again, I try to do some vocabulary to start our notes. Again, I know there's a lot of words and a lot of new symbols, but I hope this is some review to ease us into the year. If this is something you've never seen before and you need to rewatch and listen again after we try some examples, that might help. So what we're going to do here is look at the notation. So the vocabulary words are here: vertical, alternate interior, which remember I tell you to look for the Z, alternate exterior, corresponding, linear pairs, same side interior, same side exterior. So those are angles. What I'm going to do is look to this picture. The numbers are kind of in different position, 1, 2, 3, 4, 5, 6, 7, 8, and ask you to kind of write in a set of each type of angle. So a set of vertical angles might be angles 6 and 8. Could also be 2 and 4, 1 and 3. Okay, so there's multiple options to put on that line there. Moving down to alternate interior angles. So alternate interior is one is inside our parallel lines So the numbers inside are 3, 4, 5, and 6, and then opposite sides. So 3 is alternate interior with 5. So that means, and again, those are equal angles there is the symbol. So angle 3 would be congruent to angle 5. Similarly, 4 and 6 would be equal as well, but those appear to be the obtuse. Alternate exterior might be angle 2 and angle 8. And there's a bunch of sets of corresponding angles. I'm going to just take some of the notation out so we can see what I'm writing here. But corresponding angles, if I started at 3 and I copy and paste down to the other 4 pieces here, 3 is to the bottom right of them, that would copy and paste to 7. So their angle 3 would be congruent to angle 7. Again, there's a lot moving up to linear pair. There's a lot of linear pairs. I'm going to just say angles 6 and 7. So the measure of angle 7 plus the measure of angle 6 would always add to 180. Those form a line together. Same side interior. So a little bit different. If we're looking across the transversal, I'm going to stick to the left side of it. And inside would be 4 and 5. Now 4 looks smaller than 90 to me. If I trace over the two sides, 5 looks more obtuse. So if I kind of take those two little drawings, it didn't let me do it. Let's undo that piece. If I undo that little drawing, what I can do is I can grab, it didn't. I was going to try to grab the two pieces and show you that they make an angle. But think about this too. If 4 copies to 8, wouldn't those two add to 180? So therefore, 4 and 8 are equal. And we know 5 and 8 add to 180, then 4 and 8. 4 and 5 would add to 180. So same side interior would be angle 4 and angle 5. Same side exterior might be 2. I'm going to just jump ahead and 7 down there. Okay. Looking at algebraic examples. So how do we use those words to help us out? Example 2. Here they did give us the fact that those two lines are parallel. So line L and line M are parallel to each other. Find the value of x and the measure of each angle. So this is something a couple of you were skipping over on the very last classwork assignment for the Notes in Classwork 101. Please make sure you're reading after the and. Again, stopping at the x value is algebra. We want to be taking it a step further. So looking at the two angles, they're kind of giving us an expression for. The top right here is denoted by twice the value of x plus 25. The top right here is 3 times the value of x plus 10. Those are in the same position. These are called corresponding angles. And we know corresponding angles are equal. So what we're going to do is take those two expressions and set them equal. So 2x plus 25 equals 3x plus 10. And if you want to work some math magic before I can finish writing this, we subtract 2x over, subtract 10 over, x is going to be 15. So that's part of our answer. And to finish this answer up, we need to sub it back in. So the substitutions are going to look like this. 2 times 15, add 25, gives us 30 plus 25 is 55 degrees. The other substitution is 3 times our value of x plus 10. Well, 3 times 15 is 45 plus 10 is 55 degrees. Now, if that mental math isn't there yet, it's been a long summer, I know, you do have your graphing calculators, okay? And if you need help with this solving piece, again, I moved this 2x to that side, and I moved this 10 to that side. That's a little stuff that might be some little rusty in our brains these days. But again, if you need these graphing calculators, 2 times 15, add 25, we do get 55. All right. And if you have the Chromebook and you click on your little launcher down here in the up arrow, you should find your graphing calculator. If not, please let me know. So moving forward to the next example 2. That didn't work. Trying to pick up there it is. So that was example 2. My apologies. Here's example 3. So looking at this notation, reading these are important. Don't just skip to the pictures, okay? Because there's important information in every little symbol you'll read. And some of this is a new math language for us. It's geometry math, not algebra math you're used to. So given L is parallel to M, that's what this is reading. Given L is parallel to M, and the measure of angle 4 equals 2x plus 43. So what I'm going to do is I'm going to circle angle 4 and write the expression 2x plus 43. Looks like there's a little dead zone on my screen here. Sorry, guys and girls. There it goes. And to continue, the measure of angle 6 is represented by the expression 2x minus 3. So there's angle 6. That's 2x minus 3. Find the measure of angle 5. So I'm going to put a question mark over next to angle 5. Well, 4 and 5 are, angles 4 and 6 are same side interior. But also, if we follow that Z, again, this magic Z is going to help us out here. We have that 4 and 5 are alternate interior angles to the right, to the left, to the transversal, still inside our parallel lines. That 2x plus 43 jumps down here. But can we just say the measure of angle 5 is twice the value of x plus 43? No, I want to know how far open it is. I want its angle measure, not the expression it's represented by. So what we have to do is set up an equation. We're going to see that 5 and 6 form a linear pair. So we're going to add these two angles, 2x plus 43 added to the other expression, 2x minus 3 equals 180. So this is one of the angles expressions. This is the other one, and we added them together. Okay. Combining like terms, same side, sum, right? So 2x and 2x gives us 4x. A 43 minus 3 more is 40 equals 180. Okay. So to solve our equation, we move our 40 over by subtraction. 4x equals 140. Apologies for my handwriting right now. 140 divided by 40 gives us an answer of x equals, oh, not divided by 140, Miss Locke. Silly me. 140 divided by 4, because it was 4x, divided by 4 is 35 degrees. Okay. So in this case, we divided by 4. X does equal 35, but we're not done. It didn't even ask us for X. We needed it to go in and find the measure of angle 5. So this is where we're going to do some substitution. So if the measure of angle 5 equals twice X plus 43, we're going to take 2 times our X value, 35, add 43, is 70 plus 43 gives us 113 degrees. And that does make sense for the context of the picture. Angle 5 looks obtuse, and 113 degrees is obtuse. Okay. From there, I am going to end our... no, I'm not, because you guys are going to need this last case. So one other little formula, it's called a formula really. It's called a postulate here. Angle addition postulate. What this means is two small angles add to a larger angle. Okay. So in this last case, these two we know made a straight line. We added them to equal 180. They're not always going to make a straight line. Okay. So looking at the picture here for example 4, we're going to read this new notation. It says find the measure of angle JKL if the measure of SKL is 31. So let's put the 31 in the picture. So we got to trace S to K to L. S to K to L is 31. And if I zoom in there, okay, means this opening here from here to here is 31 degrees. And it also reads that JKS Miss Lock. I forgot the last letter. Let's try this one again. SKL goes this direction. SKL. There we go. That angle is going to be 31. And this is where it's alphabet soup to my brain right now. The next one is JKS. JKS is 52. So the top little piece was small. This one's 52. And they're asking us for the entire angle, JKL. So we're just going to add them together. So 52 added to 31 gives us 83 degrees. I'm going to end there so I can talk a little bit about your classwork before I end the video for today. So looking at your classwork, what I'd like you to do is take a blank sheet of paper and number it. Notice here you have 1A and 1B. Okay, use these two diagrams to help yourself. So please draw out the pictures. It's really helpful. If you don't have this already printed for you, which most of you don't, if you're at home right now, please draw out this diagram first. And in the picture, put 100 next to 7, and then decide what angle 3 would be. All right. So all work must be shown as you're doing these. So redraw the pictures. Number 1B, measure of angle TUS. So let's redeem myself here. TUS. In there goes a 73. Okay. Now, if you want to leave out all the letters or the numbers, okay, as you're redrawing this on your paper, if you just want to draw the two lines in the transversal and put your 73 in there and then put the question mark where you need to find, I want to make sure you understand the notation as you're doing this classwork is really my important piece. Number 2 here is meant to be like a little puzzle. So make sure you take your copy and paste angles. So this 32, okay, is in a Z, would paste to where 5 is. So notice everything I'm doing to the pictures. I'm drawing the pictures, I'm writing it out, okay? That's going to help your brain kind of put the pieces of these little puzzles together. So angle 5 is going to be 32 degrees there. And then you can see you have a supplement, some vertical angles, right? There's a separate line over here. So this 115, I'll give you a little hint, copies and pastes here. So angle 2 would be 115. and then you can kind of go. So you're going to look for supplementary angle pairs. You're going to look for some corresponding angles, and so on. All right. So again, try what you can. If you have a question on something on your paper, put a little question mark number next to number 2 if you're unsure of it. As I'm grading your work and looking it over before you guys come to class the next time I see you, I'll have an opportunity to take a peek and see how I can help. For number 3, you're solving for x and y. My suggestion here is to find the value of y first. So a little clue is that this little angle in here has a 6y next to it. This bigger angle down here has 13y minus 10. So you have to decide what to do with those. Do you take the 6y and set it equal? That's not a z. Sorry about that. Trying to pick up my eraser. There we go. Do you set it equal to 13y minus 10? Or do you take 6y added to the other expression, 13y minus 10? Sorry, I'm trying to write fast and my Chromebook is deciding it's about done. Equals 180. So are they equal to each other? Or do they add together to equal 180? So you really have to decide about equal things or supplementary pieces. Okay, I think the back is pretty self-explanatory. There's angle 4, which again, I want you guys to get used to this notation, the measure of those letters. Try number 5. Give me the angle 1 measurement, your angle 2 measurement, and so on. Number 6, they want you to solve for the value of x, so I want to see an equation done. And a diagram to help you with number 7 is that the angles are complementary. Remember, complementary from our last notes means they add to 90. So if I help you with the diagram here, we have a big right angle and then 2 other angles in there. Maybe one is this angle named an angle 2. If angle 2 is 30 more than twice the size of angle 1, if we're using x's to represent angle 1, angle 2 is 30 more than, added, twice the measure of angle 1. So that would be represented by 2x plus 30. Simply goes in here. But you don't have anything in for 1 yet. Remember, that was represented by just an x. So we would like you to write an equation to solve that. You need a little bit more there. Otherwise, once you're done, again, please upload to a Google Doc a picture of your classwork. I don't necessarily need to see the notes done out. It's up to you if you want to include that. But again, a picture of your classwork answers would be appreciated. And we will see you soon. Thank you.